Hello and welcome to the next video of this series, that's the Fun Physics by Akib, in which I'll discuss some of tough and tricky problems which have been asked in the NEET as well in the JEE examination as well as in other medical or engineering examinations. So in this video we will discuss the infinite ladder problem which is asked from the current electricity portion in various type of the examinations. So let's begin with the video. Like if ever you saw this type of the questions where a network of the resistance that goes on and you are told like to find a resistance between the 2 points. Okay, just like in this question, you have been asked to find a resistance between the 2 points, that's A and B. So what a network of the resistance that goes on and you are like asked to find the total or the equivalent resistance between the 2 points. You probably like thought, bro, how to even approach to this question or start this question. So infinite ladders like these look terrifying, but guess what? There are some tricks which are used by the rankers to solve them just in a few lines. Like today, I will show you that how to break this infinite chaos into a simple quadratic manner. Like no need of complex series parallel juggling, no waste of the time, like giving the 2 to 5 minutes to just this type of the questions. Not worth. I will today show you some tricks through which you can solve this question just within 30 seconds. So one clever assumption and boom, your question will be solved. So let's go with this question. Like if you first read this question, a question says that there's an infinite ladder. So first look at this point, that's infinite. Question is saying that is an infinite ladder network is made by the repeating of the two resistance, that's R1 resistance and R2 resistance, where R1 is equal to 1 ohm and R2 is equal to 2 ohm as shown in the figure. And you have to find the equivalent resistance between these 2 points, that's point A and point B. So basically, if you look at this problem, the problem first says that it is an infinite ladder. So if there's a trick, the trick now starts how the trick works here. This, as the question says that it is an infinite network, we will say that the infinite resistance will be, let's suppose X. We will put let the equivalent resistance, that network is infinite, so let the equivalent resistance हम रखेंगे X के बराबर. We'll put the equivalent resistance equal to the X. So when we took the equivalent resistance equal to X, so as you know, if you add 1 or if you subtract 1 to any infinite quantity, its value doesn't change. It's like a general rule. Now, if you add a 1 or if you subtract a 1 to an infinite quantity, its value won't change. ना it's like कि समंदर में से 1 कप पानी उठाना या समंदर में 1 कप पानी डालना, उससे तो समंदर के पानी का वैल्यू चेंज नहीं होगा ना, उसका वॉल्यूम तो चेंज नहीं होगा ना, वेल उसके वॉल्यूम पे उतना ज्यादा फर्क नहीं आएगा, बिकॉज समंदर में क्या देयर आर लाइक मिलियंस ऑफ टन्स ऑफ वाटर रिमेन्स देयर. सो 1 कप से क्या ही फर्क पड़ना है. सेम कंडीशन है कि +1 करने से या -1 करने से इस होल इन्फिनाइट इस सेटअप पे क्या ही फर्क पड़ना है. सो लेट इक्विवेलेंट रेजिस्टेंस मैंने R के बराबर रखी. अब क्या होगा अगर तुमने क्या किया काम कि इफ यू टेक द फर्स्ट सेट दैट्स द R1, दैट्स R1 हमने किसके बराबर रखा है ऊपर, दैट्स 1 ओम एंड R2 दैट्स द 2 ओम. इफ यू लुक एट दिस कॉम्बिनेशन, हमने क्या किया कि वी विल कट ऑफ द फर्स्ट सेट ऑफ द रेजिस्टेंस दैट्स R1 एंड R2 फ्रॉम दिस टोटल कॉम्बिनेशन, बट इट्स स्टिल रेजिस्टेंस इक्विवेलेंट रेजिस्टेंस विल बी X, क्योंकि फर्क नहीं पड़ना है, एज द क्वेश्चन सेज दैट इज द इनफिनाइट नेटवर्क. सो नाउ इफ यू लुक एट द क्विक सॉल्यूशन ऑफ दिस क्वेश्चन, नाउ लेट्स बिगिन विद द क्विक सॉल्यूशन. If you look at this combination, here you will see this, that's R1, जो किसके बराबर, that's equivalent to 1 ohm. It's in with series combination. It's in with series combination. किसके साथ है? R2 के साथ. ठीक है? It's in series with किसके साथ? Parallel series है किसके साथ? R2 के साथ. But this R2, it's in parallel with what? Equivalent resistance. So what happens? This R1, it's in series with the parallel of R2 and equivalent resistance X. You got my point? That is the, क्योंकि ये होल बाकी जितना भी है, if you cut, हमने क्या किया काम, we cut at one set में एक तो R1 है और R2 है. This R1 it's in series with the R2 which is in parallel with the X. Okay, so this X will be equal to X किसके बराबर, total resistance, it's like equal to this R1 and R2 जो कि आपस में सीरीज में, this R1 is equal to this is equal to R, and this is in series with what, parallel of R2 and this X. This R1 it is in series with this R2 and what this it's in with series this R2 which is in parallel with the R equivalent, that it's equal to R2. If you I said that it's a parallel combination, so as you know that this is a parallel series combination formula. So now putting the value of R1 and R2, X will be equal to, like R1 is 1 ohm plus R2 के value 2 into X, that's 2 plus X, 1 plus 2X divided by 2 plus X. So यहाँ तक हमारा क्वेश्चन. Now next step we will do, we will like multiply both sides by 2 plus X. So what we will do, we will multiply the both sides with the 2 plus X, like it will be in X into 2 plus X, which will be equal to 1 plus 2X divided by 2 plus X into 2 plus X. So this 2X is both multiplied with this quantity and this quantity. It will be like twice X plus X square will be equal to, पहले इसको इसके साथ देंगे multiply, then we will do this, then it will be equal to 2 plus X plus twice X plus 2 plus X into 2 plus X. So 2 plus X will be cut off. So it will be like 2X plus X square will be equal to 2 plus X plus twice of X. So then here will be 2X and 2X will be cut off. So it will be like X square minus of X minus of 2 is equal to 0. So this is the quadratic equation which have been formed, and when you try to solve this quadratic equation, for instance, it will be like x square plus twice plus x square plus x minus twice x minus 2 is equal to 0. Now we are trying to solve this quadratic equation by the factorization method. It will be x x plus 1 minus 2 x plus 1 is equal to 0. This x minus 2 and x plus 1 equivalent to 0. So x, now put this equivalent to 0 and this equivalent to 0, it will be x is equal to 2 and x is equal to minus 1. Since the resistance can't be negative, so x will be equal to 2 ohm. X will be equal to 2 ohm. This is the answer of this question. So like it's an advanced, but it's like a self-adjust similarity. It works for any infinite network problem. So whenever you see any infinite network problem, try to put this trick into the question, and boom, trust me, your question will be solved. Now I drop a challenge for you people, like what if this R1 and R2 both were 1 ohm? Answer me in my comment section. Thank you so much.